Okay, here we have some applications of trig functions. So make sure you have a calculator handy and it's in degree mode because all of these will be talking about degrees. So the first one we have two people on opposite sides of a flagpole. So here's our flagpole. Draw a flag there just so we know it's a flagpole. Okay, here's the ground. The person on the east, so let's see, east is to the right, north, east, south, and west. So this person has an angle of elevation of 20 degrees. So here's our angle of elevation of 20 in here. And the person on the west is at 35 degrees. So they are closer. Okay, the steeper the angle of elevation, the closer you are to the object you are observing. If the flagpole is 50 feet tall, how far apart are the people? So we're going to find two distances. We're going to find the western length and the eastern length and then add them together. So for the west, I have the opposite side and the adjacent side. So that is a tangent ratio. Tan of 35 equals 50 over x. And for the person on the east side, that's also a tangent. So tan of 20 equals 50 over y. So pardon while I calculate. So I've done this calculations now. This is a division problem. And I get 71.41 feet away on the left side. This person over here is 137.37 feet away on the right side. Sorry, my pen is glitching. So if I add these two together, I will get the total distance in between the people, which is 208.78 feet apart. So we use tangent twice with the respective angles of elevation. Okay, so now we have someone standing 100 feet away from a 250-foot tall building. Glad this information is readily available. So here this person is 100 feet away. At what angle must she look up to see the top of the building? So now we're looking for this, our angle of elevation. So she has an opposite side of 250 and an adjacent side of 100. So we are using the tangent ratio again. Tan of 250 over 100. And how we get rid of tangent, we don't divide, we don't multiply, we take the inverse function. So we inverse tan it. So inverse and regular tan eliminate each other, and over here we take the inverse tan also. So whenever we're finding an angle, we take the inverse trig function. And there should be a button on your calculator to do that with. The inverse tan of 250 over 100 comes out to be 68.2 degrees. Unless you're working for NASA, 1 degree accuracy is probably fine with all of these angle calculations. If it worked for the pirates, it can work for math class. Okay, good old Susan is a brave soul standing on top of a 25-foot tower. I'm sure the tower is sturdy, but mine's just going to be not sturdy. And she looks up and sees a waterfall. Let's see if I can draw a waterfall. Water falling. I'm sure there's a mountain there somewhere. Imagine this is a waterfall. And here's the ground. Imagine also that it's actually hitting the ground and it's the same level. Okay, so she looks up at 40 degrees. So we are negating her height right now. 40 degrees here. And let's see, she must look up how tall is the waterfall? Well, that's a very good question, and I think we need some more information, don't we? Let's say, because the waterfall is in a national park, she has to be 150 feet away. So let's say it's not given to in the problem, but just for fun, she is now 150 feet away. Okay, I guess I'll add that in. So once again, we're using tangents because this is an opposite and a adjacent. So tan of 40 equals h over 150. So we multiply both sides by 150. 150 tan of 40 is 125. 0.86, so 0.9 feet. Decently tall waterfall. But wait a second. That doesn't go to the ground. That only goes to where Susan is. So we have to take that answer and add in her tower height. That's not where we add it. So when we add in the tower height, we get a very majestic waterfall of 151-ish feet. And my pad is still glitching. Feet tall. Okay. Last one. The angle of depression from the top of the building to a person in the parking lot is 20 degrees. So here's our 50-foot building. Man, people like standing on top of buildings. Yes, they do. And the angle of depression is always formed with the horizontal. So let's draw in your horizontal so we can get our correct angle of depression. 20 degrees here, angle of depression. So our triangle is drawn floating in the sky. Now, if you don't like that, you could say, okay, I'm now going to be the person in the parking lot. And I have to also look up at an angle of elevation of 20 degrees. Okay, so now you can draw your triangle on the ground, and we can figure out D, the distance the person is from the building. Okay, or D up there. Okay, but angles of depression are always made with your horizontal. They are equal to the angle formed on the ground. So let's see, once again, tan of 20 equals 50 over D. So it's in the denominator, so 50 divided by tan of 20 means that person is 137.37 feet away from the building. There we go. Super duper.